Hello all. In this session, we will try to understand two sample t-test. Just before getting into assumption and how it is being calculated, let us try understanding the real life circumstances where actually we can use two sample independent t-test. In a place, if there are two coaching institutes and we want to compare in which institute teacher quality is best, it could just be answered by the average marks scored by their students. So here, these are two different samples where we are going to assume that these two students are totally dependent on that institute, and therefore by calculating their average or mean marks in class 10th or 12th, we get to know which is a better institute. Another example is, suppose there are two different organizations, maybe Facebook and Microsoft, and we want to understand how much do they pay to their data scientist. So here, mean salaries of data scientists in these two organizations could be compared. Very popularly, it is being used in scientific field as well, or maybe medicinal example I should give here. Whenever any new medicine is being launched, before that there is always a trial done based on our two sample t-test. So very famously, placebo effect is something that we have heard in a medicinal trial, and in that trial it's the two sample t-test that we go for. Now, talking about the major assumptions we need to keep in mind just before starting ahead with this test is, firstly, both the samples need to have a normal distribution. And secondly, variance or the amount of fluctuation in both these samples should be equivalent. If both of these assumptions are not being met, somehow because of failure of criteria, we will not be able to exercise our two sample t-test. Please note it down, these two assumptions are very important. These are certain libraries that we will be importing. This is the dataset that we are using. So our dataset also, just because we wanted to keep it very near to the real life example, we have considered, this is manually made dataset, but we have considered, as this is corona time, there is suppose medicine by name X coming up, and that company claims to boost the immunity of people who consume this medicine, and we ultimately will really try to understand whether it is possible to build your immunity by the consumption of this medicine. So just before getting into the t-test, it's important to see whether we are able to meet the required assumptions. The very first assumption is variance of two samples need to be same. And for this, we have to construct a statistical test by name Levin's test. And since it's a statistical test, the hypothesis or over here is variances of two groups are exactly the same. This shows that the level of fluctuation in both the samples are similar. An alternative is that they are different. And Levin's test comes from Skype library that is present in stats module. And ultimately we are getting the statistics over here, and p-value is 4.78. Just because p-value is greater than 0.05, we can reject the alternative hypothesis, that is, variance of two groups are different, and we can say that variances of two groups are same. This revel over here is coming from NumPy, and basically we are just tuning our data set to one-dimensional data. That is what exactly is happening here. So as of now, what we have learned is why to use two sample t-test, what are the assumptions of two sample t-test, and we have just seen the first assumption, that is variance of two groups should be same. Now moving ahead with the second assumption, this is with respect to the normality assumption. And to see whether our both the samples are coming from normal distribution, we have again plotted QQ plot. Though this is bit tricky here when we are looking at it, since these points over here plus these ones are also pretty far from the red line that we are seeing, and this should not be the case, but still we are considering it to be normally distributed. Another way, or a better way I could say, since it's coming from statistics side, is Shapiro test. And Shapiro test is a better way to move ahead, and I am not showing Shapiro test in this video since I have already covered in previous video, and also I want you to go back and just see how Shapiro test is done. Then we are going with the final hypothesis testing for two sample t-test. And in this case, our null hypothesis is medicine does not impact the immunity. So whether you are consuming it or not, your immunity will be same. An alternative obviously tells that there is significant improvement in one's immunity post taking this medicine. And this test again comes from Skype library, and this is something that we have to keep in mind. Whenever we are going for two sample t-test, we have to use t-test underscore ind. And here we are getting p-value that is far less than 0. Okay, though it's starting from 3.1, but here it is minus 0.8. And just to prove this point, we have used if-else condition. And this particular if-else condition, we are telling that if this value is less than 0.05, please give us output in form of rejecting the null hypothesis. And we are getting output in form of rejection of null hypothesis. Since we are rejecting the null hypothesis, our conclusion is that this particular medicine really boosts one's immunity. So what has actually happened from medicinal side? They just took some random sample, or certain people were just decided randomly. Few of them were given placebo, and other set of people were given this particular medicine. Over period of time, both of them were tested, and their level of immunity by some barometer was also tested. And people who consumed this medicine, their immunity became better over period of time with respect to other people. And since it's a very controlled set of experiment that goes in, other than this medicine, these two groups are treated equally, be it the level of sleep, water intake, and anything else. There is no other different thing that is done between these two groups other than this medicine. So this is how two sample t test is used in real life. Thank you.